Let's get started. All right, let's get started. I can cut this out.
The Zoom meeting projected, or
It's just a projection of videos, nothing but no interactions.
so? Okay.
Is everybody ready for this most amazing project videos? All right, we're gonna start the class. I think there are some people setting up the posters. So this is gonna be the lightning videos, 1 minute each, and you're gonna see something like 70 videos starting now. And then we're gonna see you guys all up there on the posters, okay? All right, I'm so looking forward to this.
The motivation behind this project
I think I have a lot of what?
Today, our two groups are excited to present our joint project, Automatic Corpus Level Inconsistency Detection with Large Language Models. The motivation behind this project. Today, our two groups are excited to present our joint project, Automatic Corpus Level Inconsistency Detection with Large Language Models.
Hey, Jenny, can you go into
Over time, knowledge
uh,
inconsistencies.
PA Master and turn it up?
Posing challenges for downstream applications. Yet, while students pair or document level inconsistency detection has
Sound?
No.
You can hear it. I mean, it is playing.
level inconsistency. Today, our two groups are excited to present our joint project, Automatic Corpus
Can you
Level
go
in
back to
Consistency Detection with
class card?
large
We
language
shouldn't
models.
broadcast
The
this right now.
motivation behind this project stems from the fact that over time, knowledge repositories accumulate
It's
inconsistencies that
it's
undermine
loud in here right
their
now.
reliability, causing
Could
challenges for
everybody
downstream
quiet down?
Is
applications.
the audio coming
Yet,
through
while students prepare
media?
for document level inconsistency
We
detection
cannot
as
tell if we
corpus
can
level
hear the
inconsistency,
video.
corpus level
Please stop
inconsistency detection
talking.
remains largely
Mic
unexplored.
check.
To address this gap, we have made
Jenny, can
three
you boost
main
it all the way up?
contributions. First, we introduce a novel task, corpus level.
So please
Is that
Today,
the
our
audio?
two groups are excited to present our joint project,
Let's start
Automatic
all
Corpus
over.
Level Inconsistency Detection with
Let's start all over. Monica, if you could just reintroduce, and then you'll see yourself there,
Oh, we have to start.
and then we'll go to slide.
All right. Hello, hello. I think we're waiting for the start. All right. Hello, everybody. Welcome to the final project expo of CS224V. We have about 150 people, and we have worked really hard to get to this point. I think that you guys all know that. And then we are here to see what we have done this whole quarter. And so the program here is that we get these 1 minute lightning videos, about 70 of them, and then we go upstairs and you can talk to all the people who are actually doing all the work. All right, let's get started.
Today, our two groups are excited to present our joint project, Automatic Corpus Level Inconsistency Detection with large language models. The motivation behind this project stems from the fact that over time, knowledge repositories accumulate inconsistencies that undermine their reliability, posing challenges for downstream applications. Yet, while sentence pair or document level inconsistency detection has been extensively studied, corpus level inconsistency detection remains largely unexplored. To address this gap, we have made three main contributions. First, we introduce a novel task, corpus level inconsistency detection. Second, we present the indicator benchmark for its claim corpus subtask. Lastly, we propose a corpus level inconsistency detection system called ACID to tackle this problem. Our system operates in three modular stages, each leveraging the power of LLMs. In the first stage, the system identifies and extracts all claims from the corpus using an LLM. In the second stage, the system retrieves relevant passages from the corpus as evidence to verify each claim, querying with the claim and additional LLM-generated queries. It then relies the retrieved evidence using LLMs to ensure usefulness. In the final stage, the system assesses the consistency of each claim against the retrieved evidence using a multi-expert system, which consists of an LLM personified verifier committees. Given the high computational cost of the claim verification stage, we also explore distilling this subsystem into a smaller multitasking model after achieving optimal performance. And here's a sneak peek to our demo, which includes the inconsistency found and also the reasonings behind it made by our verifiers. As a final note, while our experiment primarily focused on Wikipedia corpus, it's important to emphasize that the ACID system is designed to be broadly applicable to any free text corpus, including private or corporate dataset, such as software documentation, policy manuals, and research archives. Additionally, ACID functions as a human-in-the-loop tool, assisting content maintainers, such as Wikipedia editors, by automatically detecting inconsistency and provide supporting evidence to streamline the verification and correction process without directly making edits to it. Thank you very much for listening. Please stop by our poster booth to learn more.
We created a RAG chatbot that gives detailed answers to students about Med 275 and directs them to relevant course materials. The answers include lecture timestamps and reading titles that students can refer back to. For queries like Tell Me More, we keep a queue of previously retrieved documents that might be useful for later queries. As you can see, the chatbot is able to use these documents to expand on its previous response. The chatbot can also answer medicine-focused questions such as what causes lung cancer in never smokers, It is able to directly answer the question and then provide further information. In this case, that lung cancer in never smokers occurs more often in women and in the Asian population. The next query is, how do doctors diagnose lung cancer? The citations allow us to learn more information about the given topic. For example, this response talks about the LungRAD system for lung cancer diagnosis. To learn more about this, we can look at the citations and go to the relevant part of Lecture 1, which is indeed talking about the LungRAD system.
Hi, our project focuses on the improvement in RAG performance by not only enhancing document preprocessing pipelines for complex documents, but also devised a new information retrieval strategy called the user-enhanced RAG, which is mitigating the problem of traditional RAG struggling with contextual nuances when there are many similar documents ingested. For instance, when asked what growth trends has the Korean e-commerce market shown over the last 20 years, a typical RAG pipeline might retrieve generic information about e-commerce growth, missing the focus on the Korean market, especially when there are many reports about e-commerce. We've addressed this problem with user-enhanced RAG. Let me demonstrate this effectiveness by asking the same question to our pipeline. As you can see, the system retrieves a broad set of potentially relevant documents. Next, you, the user, selects which ones truly matter. So I'll choose this one. So then the pipeline performs chunk-level retrieval on the selected documents, and this ensures for greater accuracy. And as the results demonstrate, it's able to answer the question correctly, strictly grounding the answer on the e-commerce growth in Korea. This small step of user intervention significantly improves the results, especially in enterprise scenarios where precision is critical.
Hello everyone. Today I'm demoing our CS224V final project, the investment planning agent. We can start the conversation. Let's see, M26. Let's see, we have 100K USD. Let's see, we tell it come here. Let's see, we pretend we don't know what does it mean. We can actually ask it back. The agent will try to first answer our questions, then prompt again. I think at this point, all the required field has been filled in. All the previous conversation was managed by a Genie worksheet. What happens here is we first generate a draft plan. Next, we utilize SQL to actually query a pre-populated database, try to fetch the best matching investment details. Now we have the final plan. Let's take a look. It says, you need to allocate 40% of your budget to the stock section. And here are some recommended stocks. It also gives you reasons, the mathematical reasons, like what criteria it uses, the RSI score, the MACD score, as well as the 5-day return, the 1-month return. We can ask it to refine the investment plan. Hopefully we will get a new plan that better meets the user need. Now the new plan is here. Let's see what happens. Instead of crypto, this time it suggests us the stock indices. Yep, I think that's what the agent can do.
Hello, everyone. Today we're going to be talking about complex Sparkle query generation. The traditional chain of thought approach is very limited in that it only goes in a single sequence of steps, which must restart from the beginning if one of the steps fails. And this is not great because there's no systematic way to compare alternative approaches or bifurcate, and there's limited availability and ability to backtrack and try variations. Instead, we're going to be implementing tree of thought, which systematically saves and explores multiple solution paths. This can backtrack and try variations, which is great, and it maintains a full history of attempts to learn from failures.
Our data set takes about 10 minutes to run, and so we're going to skip this and give you an example question, which is about finding the founder of a type of geometry. At every step in the tree, we generate 3 children, which represent distinct pathways of thought. And we pursue these pathways with 3 children per every parent node, and we kill off nodes that represent pathways that are not leading to success. Once we reach a successful pathway, we found our answer and we stop. Thank you.
Imagine watching a CS106V lecture late at night and you're stuck on a tricky concept. No professor, no classmates. What do you do? That's where our conversational agent comes in. I'm Nama.
And I'm Liv. We built a personalized live agent designed specifically for CS106B. The goal is to enable question and answering on demand, just as students would do in a live in-person setting. Our conversational agent is trained on lecture transcripts and allows users to query for time-specific information, just as you can see in this example here.
We use Llama integration with Genie retrieval to deliver accurate conversational responses. Our final model outperforms baseline models, achieving an overall accuracy of 86%. In our user studies, students found it useful and accurate for summarizing lecture segments, providing additional examples, and verifying understanding of complex ideas.
If you're curious about how this tool can improve asynchronous learning, or just want to see it in action, stop by our station. We'd love to show you how it works.
Hi everyone, today I'll be presenting the KQD bot project. The goal is to improve our original RAG system, which answered listener queries and guided listeners to relevant KQD podcasts that answered their questions. So this was our original system, and it so often struggled with hallucinatory prompts, temporal prompts, and offered incomplete responses. As an example, let's ask our original system, what's the best ice cream in the Bay Area? And as you can see, it does successfully generate a response, but only identifies one relevant episode that talks about Bay Area ice cream. This is incomplete as the archives are vast and there are other episodes that touch on this topic. So due to these errors, our goal for this project was to enhance our original system through integration with WikiChat. With the WikiChat setup and additional implementations for temporal re-ranking, we hope to enhance our system's accuracy. So this is the improved system. When we ask it the same question, you can see that it performs better as it successfully pulls all relevant episodes about Bay Area ice cream. You can also click on these citations to access the relevant podcasts and audio snippets. That is all, and please stop by our poster to learn more about implementation and evaluation.
StorySmith is a task-oriented agent for storytelling and narrative analysis. Unlike general models, StorySmith focuses on putting the user in charge of their creative journey and is trained to assist users with their creative needs while ensuring that control remains entirely in their hands. StorySmith runs using a prompt-based programmatic policy, which uses intent classification to determine what functions and prompts to use next. This ability to dynamically adapt to user needs makes our agent extremely flexible and robust to unhappy paths, while still having great memory and response capabilities. Beyond workshopping, our agent is also capable of storing and retrieving user stories in a database, as well as evaluating story similarity, which I'll pass to Stephen.
So in terms of similarity retrieval, our goal is not just to compare the stories from token to token, but really to understand where the story flows from point A to point B. To do so, we do some pre-processing, and then we extract the top 3 most likely forms that the story takes, and then we embed them for future retrieval. In this way, we hope to have a better understanding and grasp of where the story is going. If you're interested in our AI agent and similarity retrieval, feel free to stop by our booth. We'd love to chat.
This is CAPT, or CAPT, a conversational agent for psychedelic therapy. CAPT is a proof of concept that shows the immense potential of LLM agents dealing with mental health support, specifically with psychedelic-assisted therapy. CAPT makes use of a RAG model, an index vector store, and an intent classifier to come up with this interface that you see here. It can help users with general queries about psychedelic experiences, what to expect before, during, and after a psychedelic therapy session, and it can even help them find clinical trials near them that they might be eligible for. CAPT provides personalized, scientifically backed support, helps users understand treatment protocols, manage their expectations, and navigate the complex emotional landscape of psychedelic experiences. CAPT also follows up-to-date harm reduction protocols and ensures that the user is safe at all times, providing emergency resources if needed.
Hi everyone, this is Emily and Allison, and we'll be presenting RoboMind, robotic decision-making powered by an LLM. It's estimated that over 1 million adults will need round-the-clock assistance by 2035. We're hoping to use robots to provide that assistance.
Our vision is to combine the physical ability of a robot and the language processing of an LLM to create a robot that can complete a wide array of tasks without detailed instructions.
We started with existing robot instructional code from Virtual Home, a household task simulator.
For the context, we included a list of objects and their properties, the actions and their pre- and post conditions, and a description of the robot's role.
When the user queries the LLM, it'll produce robot instruction code that is compatible with the Virtual Home simulator.
In this example, given the prompt, "My dog hasn't been fed yet," RoboMind infers that it should feed the dog, and it outputs a series of steps to find the dog and give it dog food.
For more information, please check out our poster. Thank you.
We built a conversational on-the-fly information seeker to answer user query from a huge body of news articles. Our system first generates Python classes called schema. This defines the information fields such as location and some sub-event types as shown by the class inheritance. Then our system comes up with follow-up questions. According to the user's response, the system will update the schema. The user may provide further details to the system or clarify what their intent is. The system then retrieves a handful of relevant articles and can aggregate information such as summing up the total number of events. There are only 2 questions asked and 2 articles retrieved in this quick demo, but you can always add more. As a comparison, approaches using only raw articles but not the schema both fail to aggregate events. But when using the schemas, we can successfully aggregate and generate answers based on the retrieved articles. More details at our poster.
If you are a student looking to gain a solid understanding of the learning material, you should definitely check out our app. By specifying the study area, education level, and demonstrate your question, we are able to generate learning materials for you. The way we are doing so is that we firstly identify the concepts related to the question and then retrieve information from Wikipedia based on those concepts, as it serves as a reliable and widely used source for providing knowledge. After reviewing this knowledge, we have provided quizzes to test your understanding and assess the correctness of your answer. Finally, we will provide personalized feedback based on your quiz performance, highlighting the strengths, areas for improvement, and future study advices. If you have any further questions related to other materials, feel free to ask again.
Our project introduces Storm Report, an advanced LLM system designed to generate concise, well-balanced reports on recent news or controversies based on user queries. Building on Storm, we enhance the pre-writing phase with a graph-based mind map to ensure comprehensive coverage, which is used in the conversation simulation as well as generating the article itself. Storm Report also adapts its information retrieval process by leveraging the latest web content, ensuring the report stays current. Finally, through prompt engineering, the system maintains a writing style and tone consistent with professional news articles.
Our evaluation process is split into 2 parts. The first part is an evaluation of style, and the second is the evaluation of factuality. And our evaluation results show that Storm Report significantly outperforms Storm in maintaining style with a 24.7% improvement, while also preserving Storm's accuracy. Additionally, our system outperforms GPT-4o in accuracy by 158%, demonstrating the feasibility of generating high-quality, balanced, and grounded reports on the recent developments of a given topic.
Hello, my name is Catherine, my partner is Priyanka, and today we are showing our dog adoption assistant. And so I'm going to go ahead and input this query. Can I search for Shih Tzus within 50 miles of 92602? And so what this is doing behind the scenes is that the agent is calling the Adopt a Pets API, which is going to search for applicable adoption listings for Shih Tzus within 50 miles of the zip code 92602. And so the different parameters that our adoption search function can take in are city or zip code, geographical range to search for, breed, age, and sex. And yeah, as we can see, the agent was able to get a list of different adoption listings applicable to the given parameters. Now, if I wanted to update any of the parameters, I could say, can I limit my search to female puppies? What this is going to do is then update the age parameter and also the sex parameter to female and puppy, and make sure that, and then call the Adopt a Pet API once again in order to get those updated adoption listings. Awesome. And each of these details also have photos linked with them, so you can open them up and see all of the really cute dogs that are available for adoption. Again, if I wanted to update location, for example, I would be able to say, can I update my location to New York? This can also take in a string of city and state, so it doesn't have to be just a zip code. You can also provide the city as well. And now here are the updated adoption listings, and we can click on the links to see all of the cute, adorable dogs. But what's really cool is that all of these are real adoption listings. So Adopt a Pet is constantly updated. It's a website that you can visit to see adoptable pets in your area. And so all of these are completely real and yeah, real dogs that need a loving home. So yep, thanks for watching.
Hi, today we're going to present our projects focused on agents that could read complex documents with vision and language models. Our motivation comes from several parts. So first, historical documents are important, but usually they're with low resolution image and also complex layout structure, which making current OCR systems struggle with accurate text extraction. But actually we found out that the state-of-art vision language models, such as ChatGPT, are actually good at handling small scans, but they're still facing with several issues. Therefore, we proposed our pipeline, which is shown on the left, to address these issues in several stages. And on the right is an example of the complete process, starting from the original newspaper to the final version prepared for the LLM OCR. Thank you, and feel free to visit our poster to learn more about it.
Journalism is the backbone of a democracy, but how can journalists get insights from complex databases? Meet DataTalk, an expert navigation engine designed to solve this problem. Here's how it works. With a natural language question as input, DataTalk uses an LLM to identify the most relevant tables and analyze its schema. It then understands the table structure to iteratively generate and refine SQL queries. Once the results are retrieved, DataTalk goes a step further by generating clear visualizations, making the insights easy to understand. In addition to enhancing DataTalk's visualization capabilities, our projects also extend DataTalk to navigate the hierarchy census database, specifically focusing on health insurance data. The challenge in census data includes its thousands of inconsistent schema and complex hierarchies. Our extension leverages LLM to flatten these hierarchies, annotates schemas, and integrates domain expertise to better understand census data site. DataComma is another platform that aggregates census data site. However, when asked what is the uninsured rate by age in US in 2023, it only provides irrelevant and incomplete results. In contrast, DataTalk provides a census data hierarchy, deliver precise SQL query, and successfully get uninsured rate across all age groups. It also provides clear visualization for the result generated.
Loki is a chatbot that helps users prepare for difficult conversations by simulating a dialogue with an agent with a user-defined personality, helping to improve conversational confidence and interpersonal skills in a low-pressure environment.
For example, here we simulate talking to a romantic partner about how to balance time spent together. You can choose between various agent types, including cooperative, neutral, or competitive. The neutral and competitive agents allow you to practice speaking with people who may get defensive or be more closed off. The cooperative agent can provide examples of what a healthy and productive conversation might look like so that you can model off of that in real life. However, the user's free text description of the agent is what truly sets its personality. This feature allows for the user to simulate speaking to whoever they want about whatever they want, allowing for infinite use cases. We also provide qualitative and quantitative feedback to the user, including things they did well, things they can improve on, and specific tips for their described conversation.
Imagine that you are the mayor of San Francisco City and you want to solve a problematic situation. This involves reading 100 papers that include relevant evidence from successful cases in other countries or in the United States, but this process is lengthy, slow, and painful. For that reason, we have brought to you Policy Chat, an agent that makes this process faster, efficient, and accurate. First, you have to describe the policy situation that you want to solve, so that you want to foster financial inclusion in Mission District. Don't know anything about the topic, we have a second option that combines both local papers and external sources from trusted places such as Semantic Scholar.
This agent will start the research. The agent will start answering each one of these questions to continue to generate what we call a policy memo. This memo contains 3 main sections. The first one offers a comparison schema across the relevant papers that were retrieved through this whole process. The second one offers detailed insight on specificities of each one of these papers. And finally, the last section provides policy recommendations.
Hey everyone, this is our project on Research Assistant for Chemistry Lab Notes. Just as a brief reminder, our project goal is to create an assistant that can take in chemistry experiment notes from a user and analyze them to answer questions about them and make experiment suggestions based on similar work in a corpus of documents pulled from ChemArchive. Down here is a high-level diagram showing the main components and LLM calls that went into our system. Now for a quick demo, when you start our assistant, you come to this simple interface where you can upload your experiment notes. The pre-processing in the notes takes some time, so in the interest of time, I'll switch to a tab that already has pre-processed notes uploaded. Once that step is done, you have this freeform chat interface with the assistant where you can ask, for example, what are some similar experiments I can try to improve my results? And the assistant will respond based on your notes plus context it retrieves from the corpus following some in-depth similarity scoring, including molecule comparison. If you're interested, feel free to stop by our poster. Thanks.
Hi everyone, this is Pawan and Ira. We created StoryBloom, building joyful interactions for shared wonder. It's a web app designed to facilitate meaningful parent-child interactions as they read storybooks together. Specifically, StoryBloom helps generate thoughtful, engaging questions that parents can discuss with their child at key moments in the book. As a concrete study, we grounded our project in The Giving Tree by Shel Silverstein and generated starter questions and dynamic follow-up questions powered by OpenAI GPT. With our system, parents can seamlessly navigate the book while tailoring discussions to their child's responses.
And throughout surveys and interviews, parents expressed their appreciation for the generated questions' potential to encourage self-expression and deeper connections. Parents also thought that follow-up questions were likely to elicit further reflection, but could be designed to be more engaging. So, moving forward, we plan to improve the follow-up question generation process while tailoring features to different age groups and interests and expanding to more books and genres. Thank you.
Hey everyone, so we did a deep dive into vision and language models that can be used to read complex historical newspapers.
And to do this, we developed a custom dataset of 40 images across these 7 categories to ensure that we can address many different layout types and edge cases.
The first of the 3 pipelines we explored was the Pytesseract Python package. This is used by both OpenAI and Gemini on their backend for OCR analysis and text extraction, although we observed that the text extraction that it performed was quite poor and a lot of times led to non-human readable text.
The second pipeline that we explored was Azure's layout detection model, and you can see that it starts with the original image. You can see in the second column how it segments it, and then lastly how it extracted the text. We found that it performed pretty well on segmenting and extracting text from simple and moderately structured layouts, but when we got to more complex layouts, the readability was affected by the segmentation portion of the pipeline, as it often segmented the larger newspaper page into pages that either only had a few words or it completely ignored column dividers or borders, and this often resulted in disjointed or out of order outputs.
And then our final pipeline, being the layout parser tool, had very similar issues, being the segmentation was quite flawed. So although the Azure and layout parser were similar, we leaned towards the Azure in our conclusion just because it had a faster runtime and a lower cost.
Hi there, I'm Johnny, and my teammate is Angelina. We're working on conversational AI agents for claims fraud detection. So every year, $300 billion is lost because of insurance fraud, and this is actually 1/3 of the defense budget. This results in $900 extra premium per family. So the key questions that we're asking here is, can we develop conversational agents that can help detect fraud during the insurance claim fraud process? The solution that we proposed is we have two AI agents, one that will be using voice to communicate with the claimant while collecting information on what happened, while we have another adjuster who will be looking at the transcription and then retrieving from the fraud database with questions to see what questions should the AI adjuster be asking. And finally, this AI adjuster can ask the questions real time to the claimant and have a final report in the end to see whether this could be fraudulent or not. So yeah, come check out our poster. Thank you.
In this project, we show that we can replace the existing agent policy with a more powerful, more accurate, and more scalable LLM-based agent policy. This new agent policy can handle SQL queries, update dialog states, and also generate agent actions. This agent policy can handle multi-step complex requests in natural language while maintaining the same benefits of the original agent policy. In this example, our new LLM-based agent policy can show the user the courses that they have selected while removing the old one. This policy is able to handle complex mixed initiative conversations in natural language.
We will now show two demos of our system, starting with the Yelp bot. Our LLM-based system is able to incorporate SQL results into the response, in this case a two-part question asking for cafes in Palo Alto and sushi restaurants in Cupertino. Our second example is the course enroll bot. The input query is complex, specifying multiple classes and a change of mind in the user input itself, but the system is able to handle it and even show the current state that it is tracking. Thank you for listening.
Hi, I want to walk you through our projects, Truth, Sleuth, and Trendbender. These are two AI agents that are here to fact-check YouTube videos and influence opinions. So the main problem we wanted to address was misinformation, specifically in the context of YouTube. And to address that, we wanted to provide users with fact-checked content and diverse viewpoints. So we created two agents. One, Truth Sleuth, is here to extract claims and questions from the video, consult reliable sources, cross-check results, and then generate a fact-check report. That fact-check report is then sent to a second agent, Trendbender, that will use it as well as a carefully curated corpus of articles that are grounded in the video theme to generate a comment. It will self-evaluate on that comment based on a selection of criteria that we've defined, and it will only output the best comment possible that we can then post in the comment section of the video, and then we can start engaging with real users. So we've done that. We have interesting and cool results. Come and check out our poster. Thank you.
Hi, we built a job search application where you can use natural language to query the job database. Here we see Matthias entering the user preferences. I want to work as a general manager in the hospitality industry. The preferences are sent to an LLM for parsing, and we extract atomic claims along with the sentiment and the weight. Now Matthias refines the preferences, adds new preferences, and after that we retrieve an initial candidate result list from a vector database, and the top K results are sent to a scoring LLM that assigns an individual score for each preference. And the last step is that we use an algorithm to assign the final score for each job. Here we see the selected job, we see how well the preferences align with the job, and we also see the different dimensions, how well they align. You can also change the weights for the individual preferences.
Hi everyone, we're presenting Cardio Agent. Our goal was to use LLM agents for cardiology reasoning and question answering. This is important due to increasing global burden of cardiovascular disease, the knowledge gap between specialists and providers, and accessibility challenges in rural areas. For our data, we used an internal set of 200 advanced question-answer pairs along with ground truth explanations and reference documents.
To test out our agent, we used multiple choice questions, open-ended questions similar to clinical scenarios, and then we used RAG to help the model with pulling relevant medical context to help answer these questions, as well as image captioning to help summarize the figures that accompany these scenarios. We found that the model exceeded the passing rate for MCQ type questions, but struggled with logical flow, acronyms, and self-evaluation. If you want to learn more about our project, come see our poster. Thanks.
Generating synthetic data is important in the healthcare domain as a solution to data scarcity and bypassing patient privacy concerns. As a part of an ongoing collaboration with the Stanford School of Medicine, we've developed an agentic workflow for generating realistic doctor-patient interview transcripts for schizophrenia. We generated the synthetic data for 7 different interview settings according to the methods outlined by Discourse in Psychosis, a mental health research initiative that gathers research quality interview data.
The first step to generating the synthetic data was generating a diverse set of patient profiles for people who had just been diagnosed with schizophrenia, which we did through a chain of LLM calls. From there, to generate the interview transcripts, we simulated a conversation between 2 LLMs where one LLM assumed the role of the researcher and asked questions associated with that section, and the other LLM assumed the role of one of our patients and responded. We then passed the transcripts to Llama and found that free conversational speech section was most predictive of schizophrenia.
Hi everyone, my name is Samantha and my partner Essen and I created a conversational agent for financial modeling. Namely, we created the first Q&A dataset benchmark for financial modeling and also a conversational AI pipeline that integrates data extraction with also chain of thought logical reasoning. So this here is an example of our Q&A dataset. And this is kind of a visual of our RAG pipeline as well as our agent implementation. As you can see here, the reasoning agent has access to 2 tools, the vector search as well as a code gen tool that allows it to run code to perform numerical operations.
Here's a quick demo of our financial modeling agent. You start by selecting an Excel model from the drop-down menu and proceed by asking questions. As you can see, the reasoning agent starts by extracting data from the vector database, reasons through the calculation, performs the calculation to get to the final answer. Thank you.
Hi everyone, today we present Neura 2.0, created by Stanford's Open Virtual Assistant Lab. This platform leverages AI and Unreal Engine's MetaHuman facial mapping to revolutionize social skills training for autism spectrum disorder.
Building on Neura 1.0's conversational quizzes, Neura 2.0 adds advanced features like ambiguous statements, emotional context, and hyper-realistic facial expressions.
Users now engage with 20 scenarios and 10 nuanced statements paired with tones, intensities, and context. For example, do you know what time it is conveys happiness in casual settings or anger when running late.
These scenarios feature hyper-realistic visuals and accurate facial expressions using Paul Ekman's AU system, offering immersive learning. Dynamic feedback and context-based grading ensure users practice interpreting emotions effectively.
Results show improvement in recognizing emotional cues and confidence. Feedback highlights the value of realistic visuals, emotion mapping, and empathetic grading. Neuro 2.0 bridges gaps in traditional therapy, making effective communication accessible to us all.
And here's a quick demo of it live in action. Thank you.
Hello everyone, this is Kevin and Steven, and we will be presenting about Insights Cal.
Imagine being able to uncover valuable patterns about your life effortlessly. Insights Cal helps you reflect on your habits and trends using your history and informs you about how you can improve.
Our tool automatically fetches your Google Calendar and your journal entries are easily uploaded. Then it provides you with actionable, personal insights based off of past trends.
There are 8 agents at work, all communicating with each other to eventually feed into a final reflective summary agent. Then the user can personalize that final outcome further by providing a short description of what they want, such as a concise summary of the reflection.
Insights Cal then generates personalized insights on the dashboard, such as strengths, challenges, recommendations for the upcoming week, and a schedule incorporating activities that were shown to make you happy. After testing this with ourselves and our friends, we're at consensus that this was a unique approach to journaling and an insightful experience. Thank you so much for watching.
This is Akshana, and Audie and I are building an AI language tutor. First, it allows users to kind of generate customized lesson plans. So when creating a lesson plan, we ask them questions. If they have a previous one, they can kind of rate it, give us feedback, select learning goals, and give us interests that they'd like to talk about. That takes a second, so we've pre-generated some lesson plans. From there, users can select their lesson plans and then actually interact with the lesson.
Okay, I'm gonna start a sample conversation now.
Hey! In this lesson, I wanted to focus on how to make a strong introduction. I'll show you how to introduce yourself with confidence in any setting. Does that sound good?
Yeah, that sounds good to me.
Great! First, a strong introduction sets the tone for the remainder of the context, whether it's an essay or a speech.
Okay, so I'm gonna end the call right now, and we can see that because there's not too much conversation history, we're getting a little bit limited feedback, but that's essentially the workflow.
In this project, we developed an LLM-based personalized room designer.
Given a user's text input, the system first generates the floor and wall design. It then adds doors and windows to the room. Next, the system selects furniture for the scene using Clip and Expert. Finally, the furniture is placed in the appropriate locations by solving a set of constraints.
To allow users to design their desired room, it is crucial to enable them to edit the design. Our system facilitates user feedback at each step. For example, users can request to remove a room, or they can ask for specific edits at the object level, such as adding or replacing furniture. Our evaluation demonstrates that our system outperforms the baseline by a large margin. You're welcome to visit us in the poster session.
Hey everybody, my name's Andrew, and me and my partner Avi created the LectureBot, an interactive conversational agent for CS224V lectures. First, our project started off as a very basic RAG proof of concept in which we were using Google Colab to create an experimental RAG project with no user interface. Then we deployed it, hosted it, and extended it to make it more functional with memory and citations.
Then we just tested a bunch of different cases and figured out what the chatbot wasn't good at. And then the last step is to just iteratively improve the chatbot based on the feedback. So some of the problems that we faced were that it was really bad at summarizing things, but luckily Assembly AI had auto chapter summaries. And then it was also bad when specifying specific lectures to talk about. So if I asked for a summary of lecture 2, it would actually just retrieve information from all the lectures. Then it was also like not great at answering follow-up questions because it didn't have the context required. So to fix that, we would rewrite the latest user query and then send that to the retrieval. Yeah, thank you.
Thank you.
Hi, and welcome to Recotree, an assistant able to help you create your personal website, a GitHub README, and optimize your GitHub profile to make your job application stand out. So let's try playing with it. Imagine we're currently applying for jobs for post-graduation, and we want to make our application stand out with a nice GitHub profile README. To start, let's first upload our CV and a nice profile picture of us. And let's ask Recotree to create a cool and fancy GitHub README for us. After generating it, we're able to view directly and preview directly the GitHub README from the app. And it seems pretty good. So we can ask Recotree to publish it on GitHub by providing our GitHub token. And here it is. It seems like Recotree created successfully the GitHub README and published it successfully on GitHub. And we have a link over here to check it out.
The second feature is a tool that creates your personal website. The website is grounded on your resume and profile picture. Upon uploading the resume, the user can simply query the tool to generate a personal website, which it will do. The tool also includes a preview tab that allows the user to visualize the website before deploying it to production. The link is provided here. The website is also customizable. The user can provide requests via the chat interface to add features, remove text, etc. For example, if the user wishes to remove their phone number from the website, all they have to do is ask. As you can see, the website has successfully removed the phone number. Thank you for listening, and feel free to check out our poster.
Oh heavens, not another boring article. My 5-year-old's never gonna read this. But wait, I know they love hearing fairy tales and looking at Geronimo Stilton. Let's use Stylet to customize style and format. We'll preserve semantic meaning, but present this content in a personalized manner for better engagement. So we can go in and input a sample of our desired style. So we're just gonna go in and paste that over here. Next, we'll select our desired format, so Stilton. And finally, we can go in and select this long, boring passage to convert it to the proper style and formatting. So we'll paste it in here, and we're off. So first, we're going to transfer style, boom. Next, we're going to go in and infuse format, double boom. And finally, we've got our results. So we can compare side by side. We can see the input, how styling worked, and how formatting worked. So if you want to learn more about style files, font embeddings, and the vision for this tool, come check out Stylet.
And we constructed a project on agents that read complex documents with vision and language models. RAG systems have the potential to enable scholars to study historical corpora from around the world. Many institutions, like museums and libraries, have been digitizing their historical archives for years.
Modern vision and language models, like OpenAI's GPT-4o, have enabled new applications, including turning scanned documents into segmented text and images to aid digitization efforts. But on their own, they struggle with full image scans and complex page structures, and the resulting output is inaccurate.
To solve this, we employ DETR, an object detection model, to first segment a scan into cropped images or image chunks, which are then individually fed into GPT-4o for text extraction.
To illustrate the improvements, we present the following example. When feeding an entire page into GPT-4o, it makes mistakes and hallucinates. The heavily bolded word portrait outputs to heraldic, and research becomes reversed, to name a few examples.
When fed a cropped image chunk, however, GPT-4o is able to extract the text with no errors.
Hi, our project is developing a game tutor for Hades, a roguelike action RPG, where the player's goal is to navigate through complex levels in combat while trying to escape the underworld. In order to minimize player frustration and help them grow and learn the game strategies more efficiently, we've developed a system of answering user queries regarding game tactics and strategies to be successful in specific game contexts, wherein we extract the game state through a combination of reading the save file and analyzing a screenshot of the game through a VLM, sending the query through a RAG pipeline, where online guides, such as those written by speedrunners, experienced players, and games media, act as our knowledge documents, and the LLM returns a grounded suggestion on strategy. In this example, we can see the user get recommended to select a title dash, as well as get reasoning behind why that strategy was suggested, since in this case it's effective and a spammable boon in tandem with other modifiers the player already has equipped. We envision the applicability of the system we have developed to extend far beyond just Hades to video games of other genres. Thank you.
Hi, I'm Sajid.
I'm Tony.
And our project is AutoCode, automated schema generation for hypothesis testing. Extracting insights from a large collection of similar documents is a common but difficult task because users don't always know what information to retrieve in order to test a hypothesis. Our goal is to create an LLM system that will observe the corpus, generate a structured schema, and populate its contents automatically in order to test it. We'll test the system on a corpus of earning call transcripts with a hypothesis like the company representatives talk about stakeholder value when their company's earnings does not meet expectations. And you can see in red the kinds of things we want our system to extract.
There are three main modules in our method for codebook generation. We first generate a codebook containing columns that are necessary to test the hypothesis. We then attempt to extract outputs from an example document for our codebook. And then for columns that cannot be extracted, we refine our schema by splitting the column into simpler attributes. Here is a codebook generated using our LLM system. We can see that the codebook columns capture the main information required to test the hypothesis related to earnings performance and stakeholder value.
Hi everyone, I'm going to run a demo of our agent while giving the context and motivation behind our work, so please bear with me. Arjun and I created an agent meant to identify drugs that are candidates for price negotiation, and this was done in light of the fact that 1 in 4 Americans have difficulty affording their prescription drugs, and the recent announcement by the Center for Medicare and Medicaid Services that they will be negotiating drug prices down. So this agent is actually geared towards someone in the Center for Medicare and Medicaid Services who could use this to identify drugs that are candidates for price negotiation. The agent is built on the Genie worksheet framework and heavily relies on the semantic parser and SQL language to turn natural language queries into SQL queries that can be used to retrieve information from a database that we compiled on the commercial drug market. And as you can see from this conversation, it does things ranging from kind of figuring out how much Medicaid and Medicare have spent on drugs to their over-the-counter and prescription drug status and their cost.
Hi everyone, I'm Noria.
And I'm Brendan. And our initial research question was about personalization of large language models for education in the language learning domain. We wanted to test how good they were today with a very specific task. To do this, we used a multi-agent approach that Noria will discuss in more detail.
Right, so this is our app. A user, if they wish to roleplay or have a specific language interaction, they will type that at the beginning, and then their username will be matched to a database for the top 1,000 words essential for navigating real-world conversations. One agent, the agent you see here, role plays with the user and never breaks character. The other is educational and answers any questions they have about the conversation. A third agent is adding comments to the corpus for the user, like did not know the meaning of this verb. So here it's asking, it's saying, today I went to the movie theater. Now it's responding, which movie did you watch? And so I asked here, what is to watch? And now a third agent will add that to the corpus and know to practice the word to watch in the role-playing conversation. Thanks, everyone.
Thank you.
Hello everyone, the goal here is to build a web agent that can navigate any website automatically. The problem comes down to understanding HTML is very challenging for large language models. It requires a lot of help from humans. To give you an example, this is what the HTML for Google search bar looks like. Okay, so this is how my project works. First, it uses computer vision to detect UI elements on the page, outputs the coordinates. It then generates a plan for all the steps, probes HTML for interactive elements. Basically, it's able to condense all this into this for each interactive element. It then uses self-reflection to see whether the task was performed correctly and updates the reasoning steps and so on. With this method, you can see exactly what's going on, and it works on any website, mobile or desktop, and is fully automated. Hope to tell you more. Thank you.
This is GNBR 2.0, a global network of biomedical relationships.
Hi, everyone. This is Benjamin, and this is my partner, Aaron, and we worked on the open problem of extracting relationships and entities from biomedical texts. And we produce a prototype knowledge graph, which Aaron will show.
This is what the knowledge graph looks like after processing about 170 abstracts scraped from PubMed. If we look closer, we can see the individual graphs with multiple nodes connected by each of these edges. For example, spontaneous coronary artery dissection. The nodes between that and aspirin, we can see what article it relates to, the evidence, what's the target and source node, and the type of relationship they have, as well as other relevant metadata. As you can see, this is going to be crucial in terms of developing critical knowledge bases used by physicians and researchers for biomedical research. Thank you.
Hi, everybody. I'm Suhas Chandy. This is Angela Liu, and we've created a tool for helping researchers identify new information that challenges or adds nuance to existing historical texts. In this project, our primary source is the African Times, a series of editorials written in the late 1800s. General History of Africa is our existing secondary source, and we construct a vector database to retrieve information about specific claims or topics.
So for modeling, we have two parts. The first part of the project is finding interesting topics that are mentioned multiple times in our primary source. So we do this by extracting low-level detailed facts from each article chunk and using a cluster hierarchy to find repeated perspectives that form our high-level claims. To make the claims easily searchable for a historical researcher to explore, we add topic modeling in the final step to regroup these claims. In part two, we want to find contradictory claims worthy of further investigation. So we use LLM querying to compare the claim against both sources to find supporting and contradictory information.
We shared our findings with Professor Getz at SFSU, who evaluated the results and suggested several sanity checks for our system, where we verify our results are consistent with known historical trends. In addition, we'd like to thank our mentor Sina for all of his help during this project. Thank you.
Hi everyone! Today we are presenting our project ElectionBot. This is a bilingual QA system that employs a RAG architecture to provide accurate responses about the 2020 US presidential election, highlighting perspectives from both English and Spanish news.
We first collected news articles from November 3rd through 10th, 2020 to capture reporting during the aftermath of the US 2020 presidential election in both English and Spanish. We used the sentence transformers model to embed the articles in queries and face indexing to retrieve the two most relevant articles for each language based on cosine similarity for a given query. We used Together AI's Llama model for answer generation, as well as to determine if a question was relevant to the election before deciding to provide an answer or not. So for example, our first question was, who is the professor of CS224V? And the assistant correctly responds with the fact that they can't answer this question.
Next, we asked a more relevant question, which was asking about the key critiques of Donald Trump's campaign through the 2020 election in both English and Spanish. And here the assistant was able to pop out a couple of different reasons and also cited sources and did so in concise bullet points.
Thank you.
Our project is building and refining a Nora V2.
So Nora is an AI app that drills individuals on social skill, automates this process to make social skills training for those with autism spectrum disorder more available and also more accessible. Currently, Nora supports drilling for only the empathy module, but we focused on the talking too much and tactful responses modules instead.
Currently, the Nora technical flow has two parts to it. First is a pool of leading statements and answers to ask or say to the user, as well as a grading prompt which identifies responses as good or bad and provides feedback to the user.
We had two goals: to understand and refine the existing grading prompt and also to build upon the existing UI for gamification.
For our first goal, we performed 15 experiments with different grading prompt phrasing and length, as well as identified and addressed problem patterns in Nora responses. Finally, we were able to test this live on the Nora UI.
For the UI changes, we created 10 plus page designs on Figma, including a tiered point system, customizing user interest, positive reinforcement, measurement of mastery, and also removal of time pressure.
Thank you for joining, and learn more about our project at our poster.
Hi, I'm Jenny, and this is Flora, and our project is Data Talk. We were motivated by looking at government defense spending, where there's a need for more transparency to see where the money is going. There's a lot of public data, but it's structured and unstructured, making it hard to find and parse information. Structured databases, we need to use SQL, but it's hard, so that's where Data Talk comes in, where it can generate SQL queries from natural language and then query databases with that.
Cool. So for this project, we set up a data ingestion platform to send ingestion data to DataTalk. So users are able to ask natural language questions to DataTalk, which uses a SQL backend to execute these queries and retrieve information. So for our progress, we've basically been able to set up our data ingestion platform, and we've been using the DataTalk platform to test this. In terms of our future work, we're hoping to add data ingestion log screening and also tailoring our LLM functionality to better answer queries.
Thanks.
You.
Hi, this is our project, the Grant Apply Agent. The current grant writing process is overwhelming for under-resourced communities that don't have the time or technical expertise to parse through grant requirements. Our goal is to break down these technical barriers. Built on Genie worksheets, our agent guides users through finding a relevant grant and completing the application's required fields. It can also answer questions about the application fields that the user doesn't understand. Most importantly, the agent can refine long-form responses based on the grant's evaluation criteria, like we see here with the project description. Should the user choose, it can even provide a rewritten version based on this criteria. This project was a valuable learning experience as we encountered challenges in working with long database fields, such as grant descriptions, and also with developing the feedback loop based on evaluation criteria. Our evals revealed that users most valued the feedback and refinement feature, and we hope to improve this agent to make a greater impact. Thank you.
Hi everyone, I'm Michael.
I'm Arnav.
And this is our project, Rule Induction Learning for Multi-Stage Language Model Programs.
LLMs often fail on tasks that require complex reasoning across multiple criteria, and we would like to provide a set of defined rules for the system to learn and apply reasoning.
To do this, we introduce Rio. We start by extracting inputs, outputs, and scores by running your program. Then we use an LLM to generate features of interest and label those features of interest. Next, we learn a classifier on top of these LLM extracted features to predict the outputs or scores. And we convert these classifier decisions into plain text rules. We also add few-shot demonstrations.
We tested this approach on datasets like Banking 77 for intent classification, NLP taxonomy for labeling research papers, and Hotpot QA for multi-stage question answering. And we demonstrated gains over baseline zero-shot settings and even robust DSPy optimizers like Bootstrap few-shot and instruction tuning with Micro. Come check us out to learn more about Rio.
Thank you.
Our project builds on a prior research paper called GPT-4 Vision is a generalist web agent if grounded. The idea is that we can use multimodal LLMs and feed them natural language instructions in the hope that they can complete a task on any website. For example, if we have the task to find 3-star hotels with 2 rooms in Pune, India for 4 adults and a 4-year-old child with a check-in date of December 25th and checkout date of December 27th. Given this task, we can see the original web agent perform. And although it gets the destination, check-in, and check-out dates correctly, it does not get the rooms and guests correctly or filter to 3-star hotels before it thinks the task is done. We analyzed the original web agent and made some modifications in the hopes of creating a more generalist web agent. And you can see our web agent performed the same task. And what it does is it actually completes it correctly. It gets the destination, check-in, check-out, and rooms and guests correctly. On top of that, it also correctly filters to 3-star hotels when done.
Hi everyone, we are Shijia and Hemi. Our project is on conversational agent for escape room game tutor. Escape room game is an immersive, interactive experience when players are locked in a room and must solve a series of puzzles within a set time limit to escape the room. During this process, players are watched by the game host so that the host can provide useful and conversational hints to the players when they stuck. However, when it comes to the online escape room game, the hint system is not engaging because the game directly indicates where the player should click next. Our project develops a hint system for online escape room game using multimodality large language models. We hope to create a more dynamic and engaging experience for online escape room game. Let's see an example of our system. At first, the player is able to solve the puzzle. When the player is confused, they can ask the agent for a hint. From the response, we see that the agent successfully understands the player's current progress and confusion. The agent further instructs the player to place the black ball to the scale and record the weight. For more details, please come to our poster. Thank you.
Hi, I'm Eric.
And I'm Ethan.
And our project is a road trip planner that addresses the complexity of coordinating real-time factors like traffic and weather and personal preferences such as dining and lodging to create an optimal route. While tools like Google Maps and TripAdvisor handle specific aspects, no solution integrates them all. We aim to overcome current LLM and limitations in complex task planning by combining their capabilities with real-time data and advanced route optimization.
So here we have a demo of a chat with our bot in which we tell it we want to go from Palo Alto to New York City on a moderate budget. It then uses a combination of Google Maps and Google Places API to create a day-by-day itinerary. It splits up the route into multiple days, finding hotels and restaurants that fit your budget along the way, as well as the weather on the day that you arrive.
But say you want to stop somewhere along the way. Here we can add a stop in Vegas, and as you can see, our itinerary is updated to seamlessly provide us restaurant, hotel, and weather information for our stay in Vegas.
Now let's say we don't want to stay at the Plaza Hotel and Casino. We can ask it what other hotels it can stay at. It uses contextual clues to find other hotels in Vegas that we can stay at. You can see a full list here, and then we can pick one to route through instead.
Thank you.
Hello everyone, we are Laura and Sean, and today we'll present our project on automated policy compliance checking with SMT models and enhanced PDF processing.
Policy compliance checks are crucial for large institutions. Our project focuses on automating expense report auditing, which involves complex policies.
Current LLMs struggle with arithmetic errors and complex policies. Instead, we use them to create satisfiability model theories, or SMT, to be solved externally, resulting in a more robust pipeline. As supported by literature, parsing PDFs into Markdown ensures better LLM reasoning, and two agents collaboration minimizes hallucination and improves understanding of complex tables and rules.
LLMs failed with adversarial policies, so we experimented with different SMT conversion pipelines. The key was breaking the SMT creation process into smaller intermediate steps. We saw that intermediate steps enabled success across all policy types.
After successfully developing a pipeline for automating policy compliance, combining SMT models and advanced PDF processing, we found that the coupling tasks and collaborations between LLMs enhance reliability. Thank you so much.
Thank you.
Hello everyone, today we present LogGenius, a smart assistant supports system monitoring and error triaging with log data. Modern computer systems generate extensive logs. However, diagnosing issues in this system remains a complex and time-consuming process. One major challenge is the fragmented nature of logs. Individual log entries often provide isolated pieces of information, making it difficult to reconstruct the full operational context. Finding meaningful connection between log pieces requires manual engineering efforts. Also, log spans diverse domains. Without deep expertise in several or all relevant domains, understanding the root cause of an error can lead to significant delays. Building and chatbot provide an interface of system status inquiry, historical operations retrieval, and error triaging can transform how engineers interact with logs. By leveraging GE Worksheet and our own SQL extension is relevant to automate log analysis. LogGenius identifies contextual relationships between log entries and accelerates diagnosis process. It enables quicker incident resolution times, making it valuable for maintaining the smooth operation for all kinds of systems.
In the status report workflow, we indicate a system component we're interested in, and the bot will retrieve recent logs and summarize the current status. The bot is able to infer the target component from a fuzzy name, and it will highlight specific events that give info about the status. Similarly, in history retrieval, we specify the details of our request, and the bot will retrieve relevant information, errors and warnings first, and less critical info second. In the summary, it will describe the notable events that occurred, answer the user question, and then finally give a summary in the end. In error triage, the bot first finds the latest error of the given component, then traces back to previous lines related to the component or the error, and finally analyzes the root cause of the error from the logs retrieved. Please check out our poster. Thank you.
We present Hypothesis Agent, an autonomous LLM agent for rigorous data-driven scientific hypothesis validation. Recently, LLMs have shown promising results in inductive reasoning in common sense domains. However, leveraging them for science presents new challenges. Specifically in science, oftentimes the hypotheses cannot be directly validated, and their probability of being true can be changed upon new observations. However, the key idea is that even though the main hypothesis itself cannot be directly validated, their implications oftentimes can.
This is our overall framework. Given a natural language hypothesis, we ask a statistical agent to generate a sub-hypothesis that is implied by the main hypothesis. This sub-hypothesis, together with the data, is passed to a SWE agent, which implements the code for hypothesis testing. This agent will output a p-value that will be evaluated to determine if there is sufficient evidence to reject the main hypothesis. If not, the statistical agent generates another sub-hypothesis and repeats the process.
Our evaluation shows that the falsification framework significantly outperforms baseline LLMs while controlling for false discovery rates.
Built an agent that determines whether or not a receipt is compliant with an institution's expense policy. So in this case, we're looking at a Uber receipt that I got on my way back from SFO just the other day, and we're comparing against Stanford's expense policy. So we start by extracting the receipt's information, so extracting from the PDF. We then search against the policy corpus for relevant documents. So it's an Uber receipt, so we found ground transportation. We then search for the relevant sections within ground transportation, and then we can start to analyze these sections. So we go clause by clause within the sections and compare against the receipt. And once all the sections have been analyzed, we can determine the overall evaluation and put together a final report. And so the final report contains a lot of helpful things, but of particular note is the requirements and whether or not they have been passed.
Introducing Pathways AI. We are revolutionizing career guidance by leveraging a hybrid search pipeline to provide dynamic, personalized job recommendations. We begin by capturing a user's preferences, such as skills, ideal work culture, and core values, which are collected through an interactive card sorting activity. Our hybrid search process uses the user's preferences as hard constraints on the dataset, combining sparse retrieval to filter out irrelevant jobs and dense retrieval using a Siamese neural network to refine matches. Then we further enhance accuracy and introduce soft constraints through our actual chatbot. Our question creator generates the initial question based on the user's preferences and the results from our hybrid search. The system uses the conversation history to optimize the prompt for each additional question, analyzing previous question-answer pairs to identify gaps in understanding and generate contextually relevant follow-up questions. Pathways AI is a promising step forward in equitable career guidance, capturing user preferences to offer reliable recommendations and showing promising results when tested by real career professionals. With future work, such as training a model for real-time sentiment analysis, we can further refine our system to meet diverse user needs.
For our project, we did a travel advisor, an LLM-based personalized travel recommendations tool. Basically, we wanted to take data from Reddit and TripAdvisor and other internet forums and put it all together in a way that's easier for users to plan their vacations around other people's experiences at those hotels. And so we can start with a quick demo. Basically, you can search for almost any luxury hotel, like, for example, the Four Seasons Boston. And on the right side in the sidebar, you'll get a description of the hotel, sort of a general description, a map that shows you where it is in the city, a book here button, which takes you to the hotel's website. And then on the left, you can interact with the agent using the reviews and any other sort of common information that you might have. For example, is the hotel pet friendly?
Hi, this is Varden and Dante, and we're presenting GameBot, which is a context-driven RPG game tutor using LLMs. GameBot is a hyper-personalized gaming experience by analyzing player behavior and coaching players to be best at what their goal is in playing the game. Our current prototype is able to provide turn-level guidance on RPG games and can be expanded into other gameplay styles in the future.
As you can see in our demo, GameBot is able to track a complex and changing set of game state variables, drawing on them to help players if they want to know, for instance, how many items are left to collect. This works because each time the user generates a query, GameBot is fed a processed overview of the game state, including information such as player location, NPC location, dialogue trees, and past actions. This is paired with system prompts that tell GameBot how to structure its response. In addition to this, the model excels at giving directions, summarizing plot points, and reminding the player of any dialogue they might have missed. To learn more about GameBot and its capabilities, make sure to stop by our table at the poster session.
Hi, our project is agents that read complex documents with vision and language models. Currently, state-of-the-art struggles at analyzing large chunks of text, mixing up distinct articles, and so we broke down this problem into two steps: segmentation and extraction/validation. On the segmentation side, we take in an image, use Tesseract to get both word-by-word boxes, but also article chunk boxes, and then combine those to get the optimal bounding boxes. We then return the coordinates, the key to trace the relevant boxes, and the refined text itself.
Given the coordinates from segmentation, we're able to extract text using Tesseract and then do it again as a validation step. We put this into GPT-4o to refine and clean it and wrap this up into the final output. For evaluation, we're using these key metrics: similarity, BLEU, precision, recall, and F1. Here's an example of us running an image through this pipeline. As you can see in the middle, the words are highlighted into bounding boxes, and based on that, they're clustered into larger chunks of articles.
Introducing Mini Nora, an AI-powered social skills trainer for ASD. 1 in 54 children in the U.S. is affected by autism spectrum disorder, often facing challenges in conversational social skills. Mini Nora provides personalized training modules, helping users practice real-world interactions like giving advice and sharing preferences. Mini Nora engages users in dynamic conversations, offering constructive feedback to improve clarity, empathy, and confidence. Its adaptive design ensures tailored training and measurable growth. With real-time feedback, adaptive learning, and performance tracking, Mini Nora empowers ASD individuals. Future enhancements include emotion recognition and expanded conversation scenarios. In this example, Mini Nora presented a situation where a friend is asking the user for advice on what classes to pick. It then evaluates the user response and provides feedback.
Hi everyone, I'm Hong Ming, this is Ethan, and our project is on agentic-driven agent creation. So we are tackling the web navigation space, which is really hard and agents do very badly in. So our proposal is to allow agents to tackle complicated tasks by creating other agents that are specifically constrained to do this complicated task. And so our main contribution is the framework to do so, and which we find beats out SOTA, at web navigation, and secondly, an improved evaluation harness to better evaluate and have feedback on our agents.
Right. So for an example of a task that we've run this on, this task is just setting your status on GitLab. So you can see the agent goes through and navigates. This is the navigator. And then it actually spawns an agent at this point. And the agent, the sub-agent is actually responsible for filling out this form and then hitting set status. And you can see that it actually completes the task. And we can have logs here, and you can see that there was a handoff happening over here. And the executor reported what it wanted to do, and it succeeded in that action.
Hello everyone. Today I'm presenting our work, Knowledge-Guided Agent System for Automating Model Interpretability. So first we come up with a data generation pipeline that uses Wikidata as well as large language model agent system to generate a pairs of high quality counterfactual data that contains different concepts. And then we using the automated generated data, we try to conduct an automatic search over all the model neurons to search for the correspondence of that particular concept. In other words, we want to see which neuron exactly is responsible for the model to have this concept of, for example, city of a country. And in the past, people also have been trying to do that, but our novelty is that we proposed a system that can automatically do this without any help from the researcher. Because in the past, you have to manually search for all the neurons. And we evaluate our works over the famous interpretability benchmarks called RAVEL, which consists of concepts, a lot of different concepts over 5 different distinctive domains. So the architecture that allows us to do this automatic search with gradient is called HyperDes. Basically, by feeding into the natural language instructions of the concept you want to discover, as well as the base and counterfactual data pairs, it's able to look at the model's internals when processing these base and counterfactual data pairs, and then determine which spot is the concept localized. And we evaluated our model with great care, and we tried to prevent any possible illusions introduced by the overly powerful model architecture. And we have observed very great results over RAVEL, even without fine-tuning on any of the training data. We only used the data that automatically generated from our pipeline. Also, we made a lot of interesting discovery of the model. For instance, the model tend to localize most of the concepts at the middle layers and the last entity tokens at the middle layer. And we also found that the feature subspaces are very distinct, produced by our auto RAVEL. And then to prevent it from causing too much illusions by overfitting on the training set, we have added a lot of constraints. For example, the sparsity loss or the numbers of tokens to be intervened on at inference time. We also explore a little bit about different model architecture choices, and we found that symmetric implementation is much better than asymmetric. And we have some future directions. Thank you for.
Our projects for anybody with dietary restrictions who struggled to find a dish to eat at a restaurant. You can upload your restrictions through text and image. And it'll take into account those restrictions and your preferences for giving you a recommendation. So here we see a recommendation for sauteed shredded potato, which aligns with our restrictions and our preferences. And if you ask for another dish,
it'll persist the previous context about that's already been provided.
Hey everyone, welcome to Lumina, our tool to help students brainstorm college application essay topics. So the way Lumina works is that students pick from an initial set of brainstorming questions and really pick questions that intrigue them or otherwise incite useful and meaningful responses. And from there, Lumina will generate follow-up questions that are tailored specifically to student responses to help them dive deeper into all facets of their life that they find meaningful and otherwise might be really useful as college application essay topics. And from these questions, they just can continue with the brainstorming process with greater context.
So students can answer questions in any order they like, and Lumina asks them follow-up questions, which encourage them to dive deeper and give more concrete examples. And then when the student is all ready, they can just click Submit for Analysis, and Lumina will take everything that they've written and let the student know their strengths and weaknesses and potential story arcs that they can use for college application essays. If any of this interests you, please stop by our poster, and we'd love to chat more about it. Thanks.
Have helped with all the different projects, and to everybody here have put in all the work. And now we're going to go into the other room for the poster session. Hopefully you have two partners who can begin sharing.